My name is Glenn Condren, and we're going to talk about a deep dive on building real-world websites with today's bits. Now, earlier on, a couple of weeks ago, some of the people talked to me about what we would talk about today in .NET Conf, and said, hey, we'd really like something about real world, something with real world in the title. We want you to give people something that they can do today with the stuff that's released, and we want you to be able to particularly focus on stuff that they're going to care about when they're trying to build an application. And so spent a little bit of time thinking about the sorts of things that I didn't typically see in demos, but that I definitely wanted to do and hear about when I was doing a real application. And so I came up with an agenda that looks a little bit like this. We're going to talk about logging and diagnostics. We want to show you how to do a custom error page, how to handle a 404, and some various other status codes that might happen in your application. We're going to put in some third-party logging providers to show you how you can hook in somebody else, some of the logging stuff that's from out there in the community. We're going to talk about configuration and how you might flow configuration for that logging through different environments for your application. We want to talk about, and at the end, if there's time, we're going to talk about publishing and what the structure of a published ASP.NET Core application is, how IIS talks to runs and directs traffic to your ASP.NET Core application. And I'm not going to go too deeply on that because the very next session is Syed, and he's going to talk about all sorts of publishing and deployment stuff. So I'm mostly going to leave that to him. We might cover a little bit of the deeper stuff that he won't necessarily get to if we have time towards the end. Okay, so that's it. They're all the slides that we have, or demos all the way down. So let's open up Visual Studio. What I have here is just a file new application inside Visual Studio. I have on GitHub, on glenc/realworld ASP.NET Core, I have this solution with a couple of extra commits showing the demos that I'm going to do in the future, some of the demos I'm going to do. My intent is to finish that solution, so there's a commit for each of the kind of major stop points as we go, and you can follow along if you want to, or check out some of the things that we're doing. And feel free to leave comments or something. But give a quick walkthrough through my startup CS. Now I'm going to assume that for the cases of this course, I'm not trying to do talk, I'm not trying to do an overview of ASP.NET Core, or I'm going to assume you kind of know the basics at least, or you have some idea of what's going on. So we're mostly going to focus on middleware, how middleware interacts, how the middleware interaction can have interesting implications for things like status code pages. So, and I want to let you finish the talk with a kind of a deeper understanding of what middleware is and how requests go in and out of an ASP.NET Core application. So, let's go here and close this, because this is the one that's up on Visual Studio, on Codeplex, on GitHub. And then we're going to look at my configure method. So, what we do inside this configure method, inside your startup CS, is we build a pipeline for handling HTTP traffic. So in its most simplest form, an ASP.NET Core application is kind of like a web server. It's a web server specifically built to handle your application and requests that your application knows about. And it runs, accepts HTTP traffic, accepts HTTP requests, makes HTTP responses. So inside your configure method here, what you're doing is kind of enabling all the capabilities that your application knows how to do. And in this case, what's happening is we do some development catch exceptions to be able to do exception pages. We'll talk a little bit about that later. But what I'm more interested in is these two pieces of middleware here, which is use static files and use MVC. What this is doing is, when you say use static files, every request that comes in, this is adding effectively a class, like a node to my pipeline. And every time a request goes through this use static files, it's going to say, is this request for a static file that I know how to serve? And if it is, it's going to return that static file, that HTML file, that CSS file. And that's going to be where the pipeline ends, and it's going to return back up through anything that was before it. In the case of MVC, MVC is going to say, does this request match any of the routes that MVC knows how to handle? And if it does, it's going to go back up, it's going to handle it, do what MVC does, and then return that response back up through the pipeline. Now, the interesting thing, though, that I want to talk about now is if it gets all the way through MVC and there is no nothing in my pipeline that handles a request, then you get a 404. And in fact, what happens is you kind of have a thing. If we give you like an inline middleware here, where we can say context and next. This is kind of a funky way of adding code directly into the middleware pipeline. And we can say context, this is my HTTP context.response.statuscode equals 404. And then because this thing is supposed to return a task, I'm just going to return task.fromResult 0, right? Now, you could imagine that what ASP.NET Core does is kind of like this. Basically, when it builds your middleware pipeline, at the very end, it adds some code that looks a lot like this, which just says, I've got to the end, there's nothing here, I'm going to set the status code to 404, and then just go back up with nothing. Okay? And this also, I wanted to do this inline middleware to kind of show you what that does, because it gives you an idea for what middleware is, which is basically a piece of code which knows what the HTTP context is that came in, and it knows how to call next. If I was to call next.invoke, then that would execute the next thing in the pipeline, the next thing down, which would, in this case, would be nothing because there is nothing there, and it would just go. Okay? So, there's like a really quick but fairly deep introduction talk about middleware and about how 404s happen. So the reason I wanted to bring that up is if I run this application and I go to a page that doesn't exist, like a blah-da-dee-blah-da-dee-blah page, let's say this, blah-da-dee-da-dee-da, and we hit enter, then I get something which is blank. What I actually get is, in Chrome at least, I get a 404 not found for that URL, and I get nothing on my screen. If I was to open it in IE, I would get the, or Edge, I would get the, an error page, because I believe they render you. We actually get an error page there. But in general, neither of these things are particularly good. You don't want them in your application. You want, in a real application that you're going to build, you want all of these sorts of things to be directed to some page that you control. You want to be able to assure people that everything's okay, or maybe you want to put a funky picture on there, maybe whatever you want to do, your emails to support, something like that. So what we're going to do is, the way that you handle that 404, we just said that the HTTP request comes in, it goes all the way down, it gets to that 404, and then it comes back up. Okay, so as it comes back up through the middleware pipeline, we have a piece of middleware, and it just hands the context straight down. It doesn't do anything to the context on the way in. But on the way back, it says, has the context got a status code in the 400s or 500s? So, and that middleware is called status pages, the use status pages middleware. All right. So if we just add the use status page middleware, and then we go back in and we F5 our application. This will take a little while. When I'm modifying C# code and refreshing the browser, it's doing a compile, writing everything to disk, starting it up. So it's a little bit slower than it might have been. Then now what I see is I've got a 404, but I've got some text on the page, and that's just what the default status code page middleware does. And your intent is that you would configure this to do what you want it to do after this. If you have a look at some of the overloads here, there's a bunch of ways to configure and handle this application, this status code middleware. What we're going to do is use a couple of the specific extension methods we've got that wrap this and do some interesting things. The first one we're going to do is use status code page with redirects. And I'm going to put in here, I'll show you a couple of features all in one go. Use status code page with redirects does exactly what it says in the name, but I'll show you what that means in a minute. But what I'm going to direct it to is this, which is a little bit interesting. I'm going to direct it to 0.html. Now, in this context, what we do is we match this 0 with whatever the status code is, which means that we need to add into here, into our www root, a static file called a HTML file called 404.html, because that's the file that it's going to try and load. So we're going to add that file. Apparently my laptop is particularly slow today. And we're going to say, what are you looking for? Nothing to see here. We're going to make this HTML page, and then we're going to run our application. And what we should see here is that status code with the redirects middleware is going to give us something different when we go to a non-code page. Now you see it's taking me to the what are you looking for, nothing to see here page, which is what we wanted, which is great. What's interesting is if we go to F12 and we refresh, well, refreshing isn't going to work because it's changed to this. If we go to F12, if we look at our network tools though, over here, what you see is it requested the ASD, and we got a 302, and it told us to go to our 404.html page, which it's a redirect, right? Which is, it's like, as I said, it does what the name says. It redirects you to the 404 page. But that's a little bit different to what we had before because my response code isn't a 404, and it means that my request has gone all the way to the server, and then it's got back a 302, and then my request has gone all the way back to the server again. So it's not necessarily what everybody wants when doing this. So what we're going to do instead, we'll show you the other type of middleware, which is use status code page with re-execute. And this one is a little bit different. It accepts the same status code. It accepts the same status code pattern, but it does something different when being executed. And what re-execute means is that when it detects a status code, it's going to detect that it's a 400 or 500 status code. That is going to go back down the request pipeline, changing the request path to whatever it is that you put inside that string in the method call. So what that means is when you look over here now, you start to see something different. You can see we got our HTML file, we got a 200 OK from the, and we have a 200 OK because we successfully resolved the HTML file, right? Which is interesting. It's a little bit better. We're not doing the double request. It still says 200 OK in our status code, but that's OK too. It's not invalid, right? You did get a request. You did get it is a valid response. But so that's kind of interesting. It's kind of cool. That gives you a way you could put a whole bunch of status codes, HTML files in there, and then you could, and then away you could go. It's not quite exactly what you want to necessarily do. Instead, what we want to do is I'm going to change this so that when we re-execute, it goes into MVC and gives me an actual view and a controller, which lets me do stuff that I care about. So what I'm going to do is we're going to change this use status code with re-execute, and we're going to change what we pass in here. We're going to change this to status code, and that's all for now. We'll just change it to status code. And then in our application, we want to go over here, and we're going to add a new controller. Okay. We want to add a controller, and we're going to call it status code controller because that's what we just called our thing, status code controller. Okay, it's going to return a view, except we don't have any views yet, so let's go and add a new folder for status code and add a view to our thing called MVC view page. Index CSHTML seems fine. And then in here, we're going to go H1, something unexpected happened. And then maybe we'll throw in a div down here, maybe say contact Seth at channel 9. How's that sound? Because he will help you with all of your technical problems. Okay, how's that? Seem good? Let's do this so that that's not actually a thing. And then we are going to go back to our startup CS to have a look at here. So /status code, assuming we set up all of our controller and our view correctly, hopefully that will work. So what's happening here is the request is coming in, it's getting all the way down to the end, it's returning a 404 or some status code happens down here, comes back up to our use status code middleware, which then redirects you back down this middleware underneath it with /status code as the request. So assuming that /status code is handled by either the static file middleware or the MVC routes, then we should get a some response back. Right, so now this is a little bit better, right? Now we've got something unexpected happened. It tells you to contact Seth, which is great. And we have this home about contact. We've still got our normal bar. Our customers can still kind of navigate around. You've still got your layout of your MVC application. And if we look into our into our tools and refresh though, there's a little bit interesting in here as well. You have a 404 instead of having a 200, and you've got all of your other requests. It's a 404 with content that gets rendered onto the screen, which is interesting. It's entirely valid, and I actually kind of like this approach to doing things. So this is a little bit better now because I get all of my layout around it and I get all of those sorts of things. But what I think is slightly more interesting is we can do, now that we have logic that can execute based upon our re-execute, then we can do stuff like we could go into our startup CS and we can maybe say, instead of doing this, I want to go to /0/, right? So now I'm going to redirect you to /status code /404, say. And then over in my status code controller, I'm going to say like integer status code. Let's accept a status code. And then I'm going to say, I'm going to just decide to use an attribute route here, just for the sake of showing a bunch of features. There's many ways you could make MVC handle this route. And we're going to say if anybody goes to /status code /this, then I want them to come to here. And now our status code renders. So then let's do something. Let's like flow the status code into our view and say, okay, now inside my view, I'm even going to say, tell him you got a at model. Tell him you got an at model. How's that? So now what we're doing is we've still got our 404 happening. It's going to come down. It's going to get 404. It's going to come all the way back. It's going to get to the re-execute middleware. The re-execute middleware is going to pass it back down. It's going to change the path to /status code /404, and then that's going to flow all the way through so that now I get over here something unexpected happened, telling him you got a 404, because all of the logic inside of our application now knows about a 404. So now you could do custom routing. You could maybe say, when I get a 404, go to a different view depending upon what I'm doing, or you could maybe change the view in Razor, or however you want to handle the fact you now have this status code to be able to play around with, which you probably could have gotten from HTTP context. One thing to note here is that earlier on when we were redirecting to a HTML file, it said 200 OK in here when we did re-execute. But when MVC is handling a route, it leaves it as 404. And this is kind of a conscious design choice that MVC did that static files doesn't. Static files are deciding that this is 200 OK now that it has successfully returned a file, whereas MVC knows that the default status of a HTTP response is 200 OK, so it doesn't modify it unless it needs to for some other reason. So the 404 stays when MVC handles a route, which actually I kind of like. It basically means you can explicitly set it in any of your controllers. There's a couple of ways in MVC for you to be able to say this should be a 200 OK when handling a thing, explicitly, assuming that you're getting into a situation like this. But otherwise, I think this is the status code that you would want because it is what happened to your application. You got a 404. Okay, so that's interesting. We have a bunch of data flowing through my application now, which is kind of nice. I have this status code, I can get it onto the view. But you kind of want to know that something like this has happened. You want to be able to go later on and find out that you're getting a bunch of weird status codes and problems like that. So we want to kind of log it. We want to log this thing, right, that we got this unexpected status code. We want to log anything that happened that's unexpected. One of the abstractions that ASP.NET Core adds, which is really nice, is this iLogger factory and iLogger. This is not a new concept, but the fact that it's there available for me, you see all I've done here, all this application does is in configure, it just accepts an iLogger factory because there's just always one available for me anywhere. In any of my types that are created for me by the framework are all activated and have an iLogger factory that they can get. And then I'm adding this console logger and adding this debug logger. What that means is that if I run this in the console, or if I attach Visual Studio to this thing, I'm actually going to be able to see the output of my application inside my output window, or the log streaming. And if I'm running it in a console or something like that, I'm going to be able to see the console output. So they're just the two loggers I've logged up. So first, what we're going to do is go back to our status code controller and show how to consume this logger. So we're going to create a constructor. We're going to accept in here an iLogger of home controller, say. We'll call it logger. And we're going to resolve that reference. We're going to control dot our way to glory. and say using Microsoft extensions logging. And then we're going to say underscore logger equals logger. And we will generate a field called underscore logger. Class name placeholder. Maybe I would want to put my constructor inside my class rather than outside my class. That's interesting that it even managed to make a constructor outside of a class. I didn't realize that was something that could happen. Okay, so we want to do this, and then we want to say make me a field called underscore logger, please, IntelliSense. Okay, maybe not. Maybe I broke it all. Let's do this. Underscore logger. We're going to do that. Okay, now down here we're going to say underscore logger dot log information. All right, and we're going to say unexpected status code, and we're going to say colon, and we're going to say status code in here, and I'm going to then pass the status code as data into the log method because it accepts an args afterwards and kind of does a string format. This is interesting for different reasons that we're going to get into in a little bit, beyond just being able to, like I could have used string interpolation in here, put like $1 in here, and I could have done string.format explicitly. I'm doing it this way deliberately, and we'll talk about that in a minute, why that is in a second. The next thing I want to show you is status code is cool, we've got the status code, but if you do get a 404, it's kind of interesting to know what it was that the person who got a 404 was asking for, why it is that they got 404s. So we're going to get this new feature called the re-execute feature, and we're going to get it, if we spell that the way I want it to, and we're going to say HTTP context, when the middleware, use status code pages with re-execute middleware runs, it actually adds a feature to the features collection called iStatusPage re-execute feature, and then, which I'm going to resolve. Except I spelt it wrong, I think. Did I? Let's zoom out. Let's zoom back in. Status page re-execute feature. I believe that is correct. Let's go find out how wrong I spelt it. I'm going to go over here, and I'm going to say search for that. Find out what its name is, because apparently I've written it down wrong in 2 different locations. Hello, search for me. Aha. Aha, iStatus code re-execute feature. Isn't that exactly what I just typed? Ah, status code, not status page. Ah, I'm so dumb. Okay, so we have iStatus code re-execute feature. Now, what this feature lets us do is say re-execute feature dot. It's basically just a type that has some data on it that we want, which is original path in this case. And we're going to say original path colon original path. Okay, something like that. Now we are saying, okay, we got a 404. Now you're going to know when 404s happen, and you're going to know what it was that people were requesting when they got a 404. So what I'm going to do though is, we said that we only had a couple of loggers, so I'm going to show another feature of something you can do inside Visual Studio. We're going to run in a console this time. By switching to the name of my app. My app name is called .NET-Conf, and clicking run. Now it's going to spin up inside of a console. I'll move this over to here, bring this up over here, and what we should see is my application starts up over here, and then when I browse to it, I start to get logging information as my app goes. So if we go to one of our ones with the network, if we refresh this page that is unknown, or that generates a 404, actually that port will be wrong, so let's go F12 and go here to slash blah 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 blah, and go like that. Then we can see the 404, and over here we got our 404 page as expected, But now over here in our console logger, we should see our unexpected there. Okay, see here, we got our log message saying unexpected status code 404, original path equals blah. So now our logging framework is set up, so it's going to log the fact that a status code 404 has happened and that we've gotten and what the path is. And that's kind of cool. It's kind of interesting. I've got a logger. I know it's doing some stuff. But what I'm going to do though is change. I'm going to go to add a different logger. So say we have console and we have debug. So if I attach the debugger, we could have seen this appear inside the debug console. But that wasn't super compelling. So what we're going to go to is going to go into our project.json and we're going to add some dependencies. Specifically what I'm going to get is Serilog Serilog dot. We want to go to extensions, logging. I'm going to add, whatever the biggest one is. And I'm going to add, zoom in so you guys can see better, presumably. Serilog dot, we're going to add syncs. And I'm going to be logging, in this case, to this thing called SEQ, which we'll show about in a minute. And I don't need this one right now, but I'm also going to add settings dot configuration for later as well. I'm going to save that. And you'll see up here in the top right that as I modify my project.json, I get NuGet packages being restored. Okay, so now I've added this Serilog logger. So this is logging through this is a third-party thing, a third-party from Microsoft's perspective, so it's something that the people in the community have. And we're going to say logger factory dot add Serilog. Add Serilog is an extension method that I don't have in here, so we're going to say using Serilog. And what Serilog expects, what we need to do when we're logging with Serilog is we want to say, we want to give it a logger. So we're going to say new logger configuration, and we're going to go dot minimum level dot, let's say debug, and we're going to say dot write to, this is the way that you configure a logger for these guys, and we're going to say SEQ. This extension method for SEQ exists because we added the package for that. And then we're going to say create logger at the end, and this string in here for SEQ, it expects a server URL. In our case, we're going to log to HTTP localhost :5, 5341. Okay, so that is how hard it was for me to add this other logger to my framework and have it start logging to something. Now, what I didn't do here, you will notice, is modify the place in my application where logging is actually happening. In this case, I'm able to modify the logger that I'm going to use independently of where my code that's doing logging is executing, which is nice because of the abstractions. So what I'm going to do now is if we actually go to localhost 5341, now I have this dashboard. This is a thing that I installed on my machine so that it's listening on that localhost 5341 URL, and it has all of the logging data all of the logs that have come through. And you'll notice I haven't hit, and I've only got the one explicit log statement in my whole application, which is the log information for an unexpected status code. But inside this event log, I have all sorts of stuff that's coming from ASP.NET itself. Part of that is because I said minimum log level is debug, so I've got a bunch of information in here that maybe isn't that useful to you as an application developer, but it's still interesting to see, and I have a whole bunch of details about what the action is that I'm trying to execute and how long it took and stuff like that. You get all this regardless of what logger you wired up. SEQ just gives, Serilog gives me structured logging, so and SEQ knows how to take structured logging and give you a view over it. So let's do something interesting now. Let's go to our help me please page, which is our one that doesn't exist, and then we're going to say, tell him you got a 404, contact Seth. Everybody should contact Seth, tell him there's a 404 on the page. It's pretty important. And if we come back here and we refresh our view, there's a lot more logs in here now, and we can see just here inside of our log that we have this unexpected status code 404. Someone was trying to get to this page called help me please. We don't really know why. And there's something else that's a little bit interesting about this. Now, earlier on, I said that when I did our log statement, I said we could have used a string format, but I didn't deliberately. And the reason I didn't is because I wanted data to make sure that data would flow in a way that Serilog would understand as structured data that it could kind of enrich my logging experience with. And what that means when using SEQ as my log sync is that it knows that status code and original path, the two pieces of information that I added, are explicitly listed here as their own types, which means you can do things now like, say, filter. We can say find, only things that have help me please in them to see how many other people are trying to get to this URL because you don't understand why people are trying to get to that URL. Or you could say find all the people who are getting 404s or things like that. Okay, and that's kind of cool. But there's also, but you could do that just kind of by searching text logs and stuff like that as well. So there's some other things that are a little bit cooler with structured logging. So we're going to do a little bit of a brief interlude to show you something, some of the benefits, and we're going to go back to our startup CS. Now what I'm doing here has a couple of benefits from my point of view. One of them is that it hopefully it's helping you deepen your understanding of middleware a little bit. The other is that it's going to show something to do with structured logging. So we're going to add another piece of inline middleware like we did before. And in this one, what we're going to do is we're going to say context.statuscode .response.statuscode, and we're going to set it to 418. 418 is a very important status code. And then we're going to say return task.fromResult. We'll just do 0 because we don't really care what's happening here in this case. Now, the bit that I want to use this to deepen your understanding of middleware, because this sometimes catches people. If I do this, what's going to happen is every single request that comes into my server is going to hit this piece of middleware. It's going to have its status code set to 418, and then it's going to return back up, and then status code with re-execute is going to happen. It's going to go back in and looking for status code /418, sorry, in this case. And then it's going to, once again, we're going to return with status code 418. So our application will never actually be able to do anything if we leave this middleware the way it is, because code with re-execute goes back down the same pipeline. So what we're going to do here is we're just going to, in order to do this demo that I'm going to do, we're going to say if response.statuscode equals 200. And so now what's going to happen is we're going to say if the status code is 200, then set it to 418 and go back up the pipeline. But if it's already not been to 200, then we're just going to return and we're going to say next.invoke. So we're going to just let it go through us in this case if. So now we're going to let it go through if it's not anything other than 200. If it is 200, we're going to set it to 418 and so on. So you'll never be able to get a successful you'll never be able to get a successful step response from the page that you're looking for, but we will be able to get to our unexpected status code page, which is kind of what I'm trying to do here, is just artificially create some interesting status codes so that we can see. So now I have something unexpected happen, telling me got a 418. And then if we go into our F12 and we have a look over here, we see we got status code 418 I'm a teapot, which is what the status code 418 is. This is the I'm a teapot status code. And then if we refresh our logging over here, we can see that we will have our 418 logging, right? But what's kind of interesting about structured logging is we could say, instead of saying, let's say status code equals 418, they know that it's an integer. What if we say greater than 404? And we get the same data, or greater than 400, and now we have our 404 and our 418. Or if we say greater than 499 to only show us any 500 requests that we've got. You can start to actually use the data that you've got inside of your logging to be able to do with this structured logging. It's great. Okay, so there's a little bit of a deeper understanding of structured logging. Let's comment this out because at some point that'll catch us if we don't. And the intent there was just, so I'm hoping now that you've got a kind of a deeper understanding of middleware, have some understanding of how middleware and status codes and our status page middleware can help, and we've done a little bit of logging. Let's continue on that logging bent and talk about some more real-world stuff. One of the things that we've done here is we've hard-coded this like localhost 5341 URL. And that's kind of interesting. That's okay, but it's not ideally what you would want to do for logging. So probably what you want to do is, in all the different environments that you're in, this is probably different. You probably don't want to push all of your logs all to the same place, regardless of whether you're logging to files or anything. Now that I've added a logger, I can remove add console. I'm going to do one brief interlude to jump down here to our web config. Now, what I want to say is that here in your web config, your standard out and log enabled and the standard out log file means that if we're logging to the console and I set this to true when I am using IIS, then all of the console out that was getting logged to that console logger would go to this file. So this gives you one way to be able to redirect console out, all console out, not just stuff that comes from the console logger, but also anything else that happens to get written to console directly with like console.writeLine, for example. If I threw a console.writeLine in here and I had that standard log enabled to true, then it would get written to that file. So I wanted to briefly do that before we come and start getting rid of some of these loggers. Now, and then we're going to look at configuring our SEQ so that we're not just hard coding this localhost 5341 URL. Now, if we go up to the top of the default, this default class, and we look at our startup constructor, we're creating this thing called configuration builder, and we're building a configuration object from it. And what this configuration abstraction is a key value pair-based logging system. So it assumes that all configuration data can be represented as a key that can return a value, a single string that can return you another string. And it does some interesting things to let that happen. This default one will, this one that's in the templates, I should say, when I say default, will look for appsettings.json in the content root here by setting the base path. You can't, once you set a base path here in a configuration, you can't find config files that are outside of that. It's restricted to that. So by default, you'll end up with one that can only look at config files inside your application. It'll look for a thing called appsettings.json. It doesn't have to be there, so if it's not there, nothing will throw or anything. You just won't have any configuration from a file called appsettings.json. And then it does the same thing for this appsettings.env.environmentname.json, which is also optional, and then it does environment variables. So let's first of all talk a little bit about this env.environmentname. What iHosting environment is an abstraction, which is iHosting environment is an abstraction. The implementation of that you are given whenever you ask for an iHosting environment gives you a bunch of interesting information that you might care about, such as the name of your application, the environment name, the web root paths, and a bunch of helper methods for environment. Is development, is production, is staging, and an is environment method to check whether or not the environment that you're in matches whatever the data is, whatever the string is that you're providing. Now, the way this environment concept works is it looks for an environment variable called ASP.NET Core _ environment. And if you go into the properties of your Visual Studio project and look at debug, right here inside environment variables, we're explicitly saying ASP.NET Core _ environment is this string called development. And what that means is that when I'm running from Visual Studio, that environment variable gets set, which means environment.isDevelopment, which we're using down here, is going to be true when running from Visual Studio, or on any machine where I've explicitly gone and set that environment variable on the machine or for the user that my application is running as, or however, as long as I've gotten just a normal Windows or any operating system's environment variables. Which means that when I'm running in Visual Studio, if I have a thing called appsettings.development, the value, that string that was the value of that environment variable .json happens to be inside my content path, then I will be able to load it and I'll read any data from it. And because it comes just after appsettings.json, my environment-specific config will overwrite any keys that are the same between these two files. So if I have an SEQ URL in here and I have an SEQ URL in here, then this one will win. And then if I explicitly make an environment variable called SEQ URL, it will override from any of the things previous. So basically last wins inside this hierarchy. Okay? And then we use the config builder to build an actual configuration root, a configuration type, and that we can use. So, given that you now know that the configuration is key value based, you give it a string key and you get a key value back. It seems like, well, okay, that makes sense. Well, why don't we would just go into our appsettings.json, say, and let's make a key. Let's call it like SEQ _ URL, and we'll set it to localhost HTTP localhost 5341. All right, so now we've got this SEQ URL, and we go back into our startup CS, and we just say, okay, well now we've done that, let's just grab our configuration object and get the SEQ URL, right? Cool. Now, this is absolutely fine if you wanted to do this, right? This is the default way that you would probably use this configuration system to do something. Now, let's execute this to prove that it actually does work. And then once we've run this and we show it kind of working, then we'll talk about how we might flow, how that data might change as we go from machine to machine. But you probably can work that out at the moment. And then let's go to what's a new value. This is the last 404 for sure. Okay, then if we go back to SEQ and we refresh, last 404. Okay, so this is the last 404 for sure. So that's definitely, so now we're still logging, we've still got this whole wire up, except that I can now modify what the URL of my logging service is, or what the file name that I'm logging to is, or whatever the data may be for where I'm logging to. There's millions of places that people might decide to log to. That's interesting. But having it just kind of hard-coded in this one app settings.json file isn't necessarily what you want to do. It'll do as a default. Maybe this is the default all the time. Maybe it's not. And then, but then you want it to change when you move from machine to machine. The testing environment is going to probably have a different place that logs go to the staging environment, to the production environment, or any other number of environments you want. The string development, staging, and production are only special in that we created an extension. We created this is development method that just says, is the env.environment name equal to, you know, development or staging or production, just to give you a nice way of saying is development, is production, is staging. You can set the strings to whatever you want and just check them yourself. It makes no difference whatsoever. So we could flow through all of those different environments by making new config files. If I made an app settings.production.json and I put the SEQ URL in there, and that got deployed with my application along with this app settings one with the local host default, then it would use the production one by default, right? But something a little bit more interesting, in my mind at least, is just go to each of the machines without any config file checked into your source control that you don't necessarily want, set the environment variable SEQ under URL as part of the provisioning and building of your server, or however you want to do it. It maybe if you're in like a cloud Azure website kind of scenario, maybe you just do it in the portal to say the URL for this website is, you know, this URL, and then away it goes. It's there in the environment, which means that environment-specific configuration is in the environment for the machine, which is a very, very nice thing to say. So that's how you might flow this data through various environments. Now, however, the way I was speaking when I was talking about this may have given you a hint. It's not the only way to be able to pull this data, to be able to configure the logger with our configuration system. You'll notice the add console logger here passes in this get section thing, and it is pulling data from this block of JSON here, saying this is my logging section and doing some information, right? Now we can do the same thing with Serolog. So the first thing I'm going to do is down here on my desktop I have this text, and I'm going to grab it because it would have taken a really long time for me to type it and I probably would have got it wrong. So I'm going to paste it in here and add this Serolog key, which has a bunch of information. Now, if you'll notice that this section of config is very, very similar to the code that I just wrote. In that these are the same names as properties that I called in my code, and it's configuring Serolog to do the same thing as what I just configured it to do in code. And then what we can do is there is a package, the settings.configuration package that I added earlier that I said I don't need yet. It gives me the ability to go dot read from, and then I can say, well, we'll read from dot configuration section in this case, and we'll say configuration dot get section, and we're going to get at the Serolog section, and too many round brackets. Okay, so now what's happening is not only is just the URL for SEQ coming from configuration, but all of the syncs that are configured are coming from configuration. So I could, just on the configuration of a specific machine, say on this machine I want all logging to go to a file. On this other machine over here I want all logging to go to SEQ. On this other machine over here I want something else. I was just joking about the last 404 because we're doing another 404 to make sure that our configuration still works. And we still have, I was just joking about the last 404. So now we have this nice, like completely configurable via configuration in environments logging system to be able to send logs wherever we want, kind of on the fly. Now, the only proviso is obviously this kind of code, the actual assemblies you need to be able to log stuff have to be there. So you can't just like go and add like Azure Table Storage logger in here, because without like adding the code that knows how to log to Azure Table Storage. But outside of that, you can kind of change things on the fly as you need. Now, we have not a super amount of time left. So what I want to talk about now is the last thing on our agenda earlier, which was the deployments, the the structure on disk, and a bunch of stuff like that. So I'm going to go in here, and we're going to say, reload. I'm going to go to open command line. By the way, this is a great extension that Mads made. And I'm going to open up where this project is. If I have a look here, this is the project with this is the place where my project JSON is. I'm going to run .NET publish, and I'm going to give it an output directory of /output. Okay, and what this is going to do is the publish command is intended to take your source code, your source representation of your project, and turn it into a structure that we intend for you to be able to effectively copy and paste over to a server and have it run, right? Have your ASP.NET Core application run. So right now, it's going to publish my application. It's going to kind of run restore to make sure everything is there. It's going to run any gulp. It's going to run grunt and all of or anything that I may have configured to make my application work. And then if we look in here, I've gone up a directory and I have this output folder. So now if we go into output and we say dir, I have a bunch of stuff. In fact, this might be easier to view in File Explorer. If we look through here, I have a whole bunch of assemblies. All the assemblies from all the NuGet packages I depended upon in like a flat list. I have my www.root content, I have my config file, I have my views, a bunch of stuff like that. This refs folder is so that Razor knows how to be able to compile things on the fly. Things like all sorts of stuff. Now, the interesting thing that I wanted to talk about here is this .NET Conf DLL. What this means is when you build your ASP.NET Core application, you get a DLL. Right? If it's not executable, you can't run it. But there is something else that's supposed to run it. This is called, by default, in ASP.NET Core, you get an application type which is called portable, which is what this is. It's portable because the output of the application can run anywhere where this .NET Conf DLL can run. And what I have is, we had this thing on my path called .NET that I used to publish my app. So now I could go .NET and I could say .NET Conf.dll, right? And this will actually go and run my .NET Conf DLL, and now I would be able to go and browse to localhost 5000, and you'll be able to see our console output here, and my app would be running. Right? Now, because all of the stuff inside this folder that I looked at is portable, it's as portable as we could make it. I could take this folder pretty much as it stands today. I think this one I could actually just pick up, drop it onto a Linux machine or a Mac, and I could run it as it stands, because the platform-specific stuff is either inside this runtimes folder or it is installed with that thing called .NET. So one of the things I wanted to do was come over here to this website called, I got here by going to .net, dot.net, to get to the other download section. And because I wanted to explain some of the breakup that you might care about in terms of you need to actually deploy this thing to a server, you need to understand which things you need to install on your dev machine versus a server versus some other thing, right? Build server maybe. So that .NET thing that's on the path that can run compiled DLLs, but nothing else, is what you get if you run this .NET Core installer here, right? So you run apps with .NET Core Runtime. That means that you get a .NET, but it doesn't have like .NET Publish, .NET Build, it doesn't have a compiler, it doesn't have all the dev tools, and you can just, so you would install this somewhere where you were going to use .NET to run something, but not build or anything like that. The .NET Core SDK, that gives you the .NET, but you get the .NET to be able to run a DLL. You also get the ability to restore, build, publish, do all sorts of other things. And then there's this Windows Server hosting. What this gives you is a thing called the ASP.NET Core module and the .NET that you can use to run your app, the .NET on the command line. And the reason that is interesting is because if we go into our web config here, earlier on I talked to you about the standard out logging being able, if you're using IIS, you can set standard out log enabled to be true, and then it will start logging content out to this whatever this file is. Well, what this web config file also does is controls, so it registers this ASP.NET Core module. So in order to be able to, this web config controls how IIS is going to run, it's how IIS knows how to run an ASP.NET Core application. You register this ASP.NET Core module, and then what it does is look for this configuration, and it will, when a request comes in that matches matches everything in this case for your app, for this application that's been created in IIS that has this web config in it, it's going to run whatever's in here, pass it whatever these arguments are, and then this is extra configuration file for the core module. Now, why that's important is if we go back out to our command line and we look at the web.config file that got generated when I did publish, you can see it has actually been replaced. Those tokens that we just saw inside Visual Studio, this percent launcher path and percent launcher args, have been replaced with the value with .NET and .NET Conf. So when you're running your application in IIS, what you're actually seeing is, what it's actually doing is running .NET Conf DLL, exactly the same as what we did on the command line, and then it's sending all HTTP traffic to a port that it tells this to listen on. It uses environment variable so that when it runs .NET Conf, our application will listen on the right port and it will send all HTTP traffic to it. So that's how you use IIS in order to deploy. So then that's why you need to go and install that server installer on a server to be able to get both the ASP.NET Core module and the .NET Runtime to be able to run your portable application. If you're on a build server or something like that, you don't need to run, then you don't necessarily need the ASP.NET Core module, but you need to be able to build and compile, and so you need the SDK. Okay. The other thing that was interesting to note, the last thing that we'll go over on this, is in the runtimes section here, we have a bunch of kind of OS and bitness, things that look like OSs and potentially bitnesses. What this is this application, this portable application type, it's as portable as we can make it, which means that sometimes some packages have native dependencies. In this case, a default ASP.NET Core application depends upon a library called Kestrel, our HTTP server that you probably may have heard about, and it has a native dependency, particularly a dependency on libuv. And so what we do when making a portable application is we just take all of the native libuvs that you might need and put them in here, because we don't know which one you might need. So we make it as portable as we can. It's possible to kind of specify and tune that, but that's kind of, you make it as portable as you can. So that's how native kind of gets handled. The other thing that you can do is you can convert this to be standalone. And I'm not going to show you how to do that, but when you do that, you put one of these things, these are called runtime identifiers, but you put one of these things into your project JSON to say, and when you build, you say, I am building for Linux, for Ubuntu, for OS X, for something. And then the output that you get is specific just to a single platform, a single operating system, a single architecture. And your output will actually have an exe in it, or a binary that can run on that platform, and it will also have all of the stuff that your application could possibly need to run. It's completely self-contained. It has the CLR, everything inside of it. For a typical web server, you probably don't want that, because you actually don't want to have 20 copies of .NET Core on the server. You probably want one copy of .NET Core that all of the different websites, web applications share, which is why you get portable by default. But I thought I would explain it so that if you guys start in a very quick way, so that you guys get a little bit of context if you start reading or start playing around with some of this stuff. Okay, and on that note, I have about 5 minutes left. So I'm going to sign off and let Sayed come and get ready so that he can talk about how to get your ASP.NET Core applications onto your server. One thing I'll get you guys to do is, if you're interested in the stuff that we just looked at, I have I said this earlier, but I'll show you the URL again. I have a real-world ASP.NET Glency/real-world ASP.NET Core where I put this code as I was running it. Feel free to go create issues and stuff on there if you want to talk to me about some of the stuff, or send a pull request to fix something dumb or something like that. At the moment, it has a few commits for the first few parts of our app, of what I was going to do today. It's not completely done yet, so over the course of today and tomorrow, I'll finish adding the rest of the kind of stages for all of our app until it gets up to the point where this one was at the end. I'll probably check in my notes about what I was doing and stuff like that as well. The slides aren't particularly interesting, but I can check those in if anybody really cares. So I can see you there. Feel free to talk to me on @ConranG on Twitter too. Thanks.